and making us have better measurements is a big part of that effort. Yeah. So I would say the later half of the 20th century until now, we have seen a lot kind of happen in these types of topics. But as a whole, the 20th century, especially in the beginning part of the 20th century, had so much excitement going on with, of course, special theory of relativity, general theory of relativity, photoelectric effect, the old quantum mechanics, and the quantum mechanics leading up to particle physics. So, and string theory. Let's not forget, we have also talked about string theory on these lives. You should definitely go back and check them if you're interested. From the start of construction to the completion of the first experiment, a decade can easily pass. This is in sharp contrast to the time scale of the processes being investigated, which occur in less than a billionth of a second. I mentioned that this is basically they're trying to recreate something that may have happened over 10 billion years ago, so sort of towards the beginning of the universe. The LEP collider imparted energies to elementary particles that were far beyond those produced anywhere else in our galaxy, except perhaps in the shock wave from an exploding star or in the final collapse of a gigantic black hole. Charged particles were accelerated by electric and magnetic fields around the tunnel so that they traversed the Swiss-French border without passports near the airport and then again at the base of the Jura Mountains 10,000 times each second. In the process, they achieved energies of almost 1 million times the energy they store at rest. Wow. Yet, these gargantuan values are still 1 million times smaller than the average energy carried by every particle when the universe was the size of a baseball. So the universe, of course, started very small, very compact, very hot, dense, energetic, and yeah, it was a very different universe, quite literally, back then. The collisions between individual particles at that time were so energetic that to recreate them with present technology, one would have to build particle accelerators with a circumference bigger than the circumference of the moon's orbit around the Earth. So it's very difficult, by the way. It's difficult enough to do this, but if you wanted even more energetic particles, then you would need the circumference of the colliders to be even bigger. And bigger than the moon's orbit around the Earth is quite impossible to achieve without getting very creative, I suppose. The voyage from LEP to the primordial universe is more than a voyage back in time. It is a voyage in scale that helps take us and our atoms much of the way from Brobdinging to Lilliput. As out of this world as the colossal detectors in the LEP experimental halls may seem, their mismatch to normal human scales is inconsequential compared to the degree to which the scales of activity in our current universe dwarf those that were relevant when atoms were conceived. Hi, Crazy Sick Wine. We're talking about atom. Can you rewind and see the first part of the live where we talked about our merger with Andromeda? The huge densities and temperatures at that time are reflected in an equally matched subatomic ferocity. Let us return to the barrage of atoms in a drop of water again, as seen under the microscope. The Brownian jumps of a dust speck are produced by the collective collisions of billions of jiggling atoms in the water, each momentarily traveling at hundreds of kilometers an hour. So, by the way, Brownian motion was also worked on by Einstein. Thank you. But a single subatomic elementary particle in the primordial gas, when the universe was the size of a baseball, carried enough energy to, in a single collision, knock the same dust speck not only right out of the water, but out of the Earth. Goodness, very extreme conditions back then, very. If we tried to ratchet up such a collision to a human scale, it would be like accelerating a rocket in space to such a high speed that upon colliding with the moon, it could kick it right out of the solar system.